Hi, I'm Daniel Rowbottom. I'm here with Cameron Richardson, NAPA Racing UK. We're here in sunny Spain, and we're here with TechMate today to find out how NAPA produce their brake pads.
Hi, I'm Graeme from TechMate. TechMate are the technical partner for NAPA. Welcome to the NAPA production facility. I'm going to be your tour guide.
Thanks, Graeme. Are all NAPA brake pads made here?
Yes, to ensure consistency and quality, all NAPA brake pads are made in this state-of-the-art facility here in Spain. The facility is ISO 9001 and IATF 16949 accredited. NAPA have stringent auditing processes when selecting factories, making sure that the material and production quality is up to scratch to ensure optimum quality. So we only use the best factories. Shall we go inside and take a look around? So it all starts here in the R&D facility. We spend millions of pounds each year on R&D.
What sort of things do you get up to then in here?
Oh, everything from conformity, product testing, benchmark testing, raw material analysis, the list goes on. Here are just a couple of the machines that we might use. The NAPA brake pad is designed to be a direct replacement for the RE part, and is also designed to meet and surpass R90.
So what's R90 then? Sounds a little bit like vehicle codes. There was a Nissan, I think, that won Le Mans in the 90s, ironically.
ECE Regulation 90 is a minimum brake safety standard for road-going motor vehicles required for all replacement brake linings. R90 calls for linings to be tested for speed, sensitivity, fade and hot and cold performance, along with other tests like shear strength. They must closely match the original equipment part.
So how do you know if a brake pad meets R90?
So, all NAPA brake pads have R90. If we look at the packaging here, we can see the R90 number on the label. It starts with the E, so this is the certification number. Also, if you look at the actual product itself, on the back of the brake pad, you will see the part number, the batch code, so we've got traceability of that product, and we've also got the R90 certification number on here as well. So R90 only really looks at safety critical aspects of the brake pad. Here we have our own set of internal standards which are much higher than R90. If you take the adhesive bond which bonds the friction material to the backplate, that's vitally important. If you imagine that obviously you've got the brake disc pulling on the friction material, we don't want the friction material to come away. If that does, that's critical. R90 says that it must be twice the force of that particular application, whereas in-house we test to 4 times that force. So the machine's basically trying to shear the brake pad. It will eventually shear it, and this is what happens. But as you can see, the adhesive bond hasn't failed because we've still got friction material.
So that's actually broke the friction material, as opposed to the adhesive. So that's interesting.
If we did see any metal here, we saw any backplate, at that point we would fail the whole production batch because the adhesive has failed.
So what other kind of testing do you do? Because obviously there's a lot of equipment in the R&D facility.
Yeah, so we look for things for overall performance, noise, vibration, harshness, pedal feel, fade, all sorts of different things, but everything we do is to ensure quality. You take this dyno for example, in there you've got a set of brake pads and a caliper on a knuckle with a brake disc, and that machine is obviously replicating the vehicle on the road. We've got microphones in there which are listening for noise. Quite often we do something called the AK master test on here. This is a lot more extreme than R90. It puts the brake pads through real world scenarios and is tested to the extreme.
Oh, so there's no job for the two of us then?
Unfortunately not. We tend to use proving grounds that better simulate real world scenarios, such as the Nardo circuit in Italy and the Idiada circuit in Spain. We also have the Mahacha test, which is a 6,000 kilometres of driving from the Mediterranean coast to the Tabaranaras desert, which is a combination of damp and humid conditions and then into a very dry environment. So as you can see, we go well beyond R90. Should we go and have a look how our brake pad's made?
Oh yeah, we don't want this tour to come to an abrupt stop, do we?
Oh, nice.
Right, let's get kitted up.
So this is quality control department then, right?
Yes, this is one of the quality control departments. We have quality checks at each step of the way.
So what is it specifically that you're checking here then?
NAPA brake pads are made to the exact dimensions of the original brake pad that come off the vehicle. We check each batch to ensure that we are sticking to those dimensions. In actual fact, the backplate is very slightly smaller at this point. The finished pad is exactly the same as the OE, but at this stage we need to allow a few microns for the black anti-corrosion coating that we apply later.
So, I guess you've got to clean the car carrier though to get these in to fit properly.
Yes.
It looks like we've got some big washing machines here. What's this all about?
This is where we clean and shot blast the backplates to remove any grease and impurities to ensure that the backplate is in its optimum condition before we apply the adhesive and press in the friction mix. We manufacture as many items as possible in-house as it gives us a better understanding and control of the quality. This is where we produce the anti-noise shims.
I bet I can tell you what they do.
It does exactly what it says on the tin. NAPA pads use a triple layer shim which they call Silent Guard. It's a premium shim, just like you would find in an original pad. This is the friction material mixing area, which is one of the most critical processes in the production of a brake pad. Each friction mix is electronically controlled and closely monitored to ensure quality. On average, probably about 21 different ingredients go into a mix. They include abrasives to improve friction coefficient and clean the surface of the disc. Our brake pads are heavy metal and copper free, which is better for the environment, but we do use softer powdered metals such as zinc, brass and aluminium to aid friction coefficient, heat dissipation and heat transfer. Fibres and resins that help us to bind the other ingredients together. Lubricants such as graphite, they help with noise and friction coefficient at different operating temperatures. Curing agents, they ensure that everything cooks up perfectly. Organic materials such as ground up cashew nut shells.
Did you just say cashew? You mean nut as in nuts we eat?
Yeah.
Wow.
So we use ground up cashew nut shells or walnut shells in modern friction materials, especially asbestos-free friction materials.
Yeah.
As a friction modifier, so
right.
It's just like a binding agent to bind everything together.
Okay. And what's this?
This is cork.
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 What's that in there for?
This is actually to help with porosity. So cork burns really, really easily. So we put the cork into the friction material mix. As it burns in the press, it generates tiny little sort of like air bubbles.
Okay.
The cork burns away,
yeah.
and that helps us with the compressibility of the brake pad.
And I've now got to put 7 kilos of this in there, right?
Yeah, into the machine.
Whoop. Oh my goodness.
We'll start to see it build up. It will bleed to
It's
start
going to take
with.
ages.
Yeah.
Can I just tip the bucket in? Well, okay. Go steady, Graeme.
Right, let's do it.
Look at that. Right.
There are that much more to go.
Hang on.
Okay, that's green. The friction material that has just been mixed comes together with the backplate in these deep mould presses. A computer controls the pressure applied, temperature and time in the press. It helps guarantee that the pad has uniform material porosity and density, which are qualities that are essential for quiet, comfortable and highly efficient braking performance. The pads need to go through the curing oven next. They need to be big, as the pad can spend between 7 to 10 hours in them. They are what we call continuous ovens, so as the pad moves through, they are subjected to varying temperatures from the ambient up to 200 degrees centigrade and down again. You can see the different temperature zones on the gauges.
So why is this process so important?
It does a number of things, including eliminating impurities, such as the bonding materials, and ensuring that there is a consistent coefficient of friction across the friction surface. These machines grind the pads flat and control the thickness. As we match the OE pad, we also add any chamfers or slots here. This is what is known in the industry as scorching. For NAPA pads, we call it pro-bed scorching. We apply 1 ton of pressure and heat the pads up to 650 degrees Celsius. This costly process is only performed on premium pads and improves initial braking, reduces bedding time, but also prolongs pad life and reduces noise and vibration. The pad is now ready to receive any accessories such as an anti-noise shim and any spring fitments. The pad is marked to receive the R90 number, batch code and part number before going in the box. So, thanks Cam, thanks Dan, taking the time to come to Spain and have a look at the NAPA Brake Pad factory.
Yeah, I really appreciate it. It's been really good. I mean, the quality control is exceptional. It's been really interesting getting insight, and I think the thing that, I mean, I've come from the trade myself, so seeing everything being manufactured in the European factories, really reassuring, and we've really enjoyed it.
Good.
Thank you.
Thank you.